Thanks for joining us today for a little science and shop lesson. Mr. Rasty is holding the camera. He's going to take us to the metal shop in a little bit, and I'm Mr. Boucher, who's going to take you through the science side of it. Well, today's topic is matter, and matter is anything that occupies space. Matter can be described in all these different qualitative and quantitative ways here. Each of these terms works together to give us what exactly the matter is that we're talking about. Matter primarily exists in four phases. There are some weird transitional phases that can be observed under the most perfect of conditions, but the most common four are solid, liquid, gas, and plasma. And here we have our example of something that you've probably heard of before, water. Solid form being ice, of course. Liquid form, we just go ahead and call that water, or high quality H2O. And inside of this beaker here, we still have liquid water, but that's not really the subject of what we're talking about in this case. We're more worried about this cloudy steam that is evaporating out of the beaker with the heat applied. And so that would be the solid, liquid, and gas form of water. Now, if water doesn't convince you that matter can apply to your life, then you should take a look at one other really important compound, or in this case, element, and that would be carbon. And carbon helps illustrate one of the most important laws holding the known universe together, and that would be the law of conservation of matter. Matter cannot be created or destroyed, but can be changed from one phase to another phase. And we can see how this works right here on our own planet in the four systems that make up our planet. We have the atmosphere, the biosphere, the hydrosphere, and the lithosphere. And so let's go ahead and walk through them with carbon to see how we can observe that no carbon is being made or destroyed and that it can change its form. So right away here in the atmosphere, we have this greenhouse gas known as carbon dioxide. Carbon dioxide helps make that sweet magic of plants and living organisms work, where plants take in the carbon dioxide waste from organisms, and organisms then can get the oxygen waste that comes off of plants when plants are making this really important thing, C6H12O6, which is known as glucose. Glucose is a simple sugar and is a regular part of our diets. In this case, another mammal, being the white-tailed deer here, is eating some leafy plants, definitely taking in some glucose there, and he's going to use that to make these things. His own carbohydrates, his own nucleic acids, his own lipids, his own proteins, and each one of those biomolecules has a whole host of important responsibilities for it. Now, all good things must eventually come to an end, of course, right? This deer will eventually die, just as this deer here did. And it would seem that carbon has reached the end of its usefulness at this point. This is like a terminal spot here. But that's not the case. Thankfully, we have these really important organisms known as detrivores, which will break this organic matter down, and actually, in the case of carbon, return a lot of it back to the atmosphere in the form of carbon dioxide. Some of it will, of course, stay in the topsoil and be used by plants, but a lot of it, over time, given a lot of time, will get buried deep within the earth under layers and layers of sediment, and will be put under enough pressure, and through time be actually changed into fossil fuels. And we use those fossil fuels in how we do regular life. We burn it in our cars, we use it at factories, things like that. And when we do, we're again releasing more carbon dioxide back into the atmosphere. Of course, I should have mentioned here, when these things breathe, they're putting carbon dioxide into the atmosphere as well. So we've actually covered three of our four spheres, or three of our four systems of Earth. So what about the hydrosphere? Well, there's always plenty of what I have boiling away on the table here by me, water in our atmosphere. And when water and carbon dioxide combine together, we get this new compound known as carbonic acid. And carbonic acid is a common form of acid rain that we have around us all the time. So here you can see how carbon, none of it was created, none of it was destroyed. It's the same carbon going through each system of the earth, and it's changing from different phases, solids, liquids, and gases here. And it's all around us, and it helps make the world as we know it. But if you're still not convinced how this applies to your life, we're going to go down to the metal shop. Mr. Rasty is going to show us how we go through the different phases of matter to build and fix things.
Hey everyone, so I am Mr. Rasty, and I'm going to talk about how we can manipulate the different states of matter in our shop to do some useful work. So we're going to talk about how we take solids, liquids, gases to do different things here in our welding shop, and then we'll go in and talk a little bit about plasma too. So we're going to use these two gases. We've got acetylene and oxygen, and they're going to make a flame that is hot enough to melt solid steel into a liquid, which can then melt two pieces together, which will freeze and make one continuous solid piece, which is called welding. So we'll talk about that first, and then we're going to discuss some plasma. For our example, we're going to take these two pieces of steel and melt them together into one piece. So first I have the torch lit with the acetylene burning. Now I'm adding oxygen to make that flame extra hot. And then I'm going to move the flame up next to the metal and start to weld them together. Unfortunately, we're at the disadvantage of using Chromebooks and cell phone cameras to do this filming, so you probably won't be able to see the puddle super well. But what's happening is that flame is heating up the solid steel to a point where it actually starts to melt and turn into liquid. Then I'm going to have both edges of those two pieces turn into enough of a liquid puddle that they will start to flow together into one puddle. And then as I move the flame away from that area, that puddle will actually freeze and join those two pieces together. And that's, in essence, what welding is. So as I move this along, it's going to take those two pieces, turn it into one piece, and that's how we use gas to turn a solid into liquid and then back to solid again. Okay, so now we want to talk about plasma and how we use plasma in the shop. So one of the things that I think is very cool about plasma is that it is the same matter that makes up lightning. So lightning itself is pretty uncontrollable and not very useful for work, I guess beyond setting Marty McFly Back to the Future. So we have to figure out a way that we can use a machine that will create its own plasma and focus it into a way that we can use. So what plasma is an ionized gas. So it's a gas that's had electricity added into it to make plasma. So what these torches do is uses these parts to add electricity to gas and focus it for work. So air will come through this torch, through the top, and it's going to hit this part here called the swirl ring. The swirl ring is going to take the gas and it's going to start to spin it and make it swirl. And that is going to help make it more accurate as it goes through. So it kind of focuses that plasma stream. You can think about it like throwing a football. The better spiral you throw, the more accurate it'll be. Or when shooting a rifle, that rifling is going to spin the bullet and make it more accurate. So that's what the swirl ring is going to do. Then that gas is going to come through and it's going to come into the end of this electrode. That air will come past the end of the electrode, and that will make it come into contact with an electric arc. So at that point, that gas is becoming ionized and becoming plasma. At that point, it's going to travel then through the nozzle and the end of the torch, and it's going to be focused and will be able to come into contact with the material you're working with. In the case of the torch we use, that plasma comes out at about 40,000 degrees Fahrenheit, so very hot, and because of the design of the torch, it's a very focused heat. So that makes it able to cut through metal right where you want it to cut and actually make pretty accurate work. So we're going to go into another shop now and look at how we can take a sheet of blank steel and use plasma to cut it accurately into something like our Sherrard S. Okay, so here we are at our CNC plasma cutting table. CNC means it is computer numerically controlled. So it's going to use a computer to tell this plasma torch where it needs to move in order to cut out the part that we have programmed in. Right now we have it programmed in to cut out one of these Sherrard S's. So it's got that program in there, and it's going to read this G code to know what coordinates the machine needs to move in order to cut out our part. So with the table all set up, we just need to put our safety glasses on, press go, and let it do its work. right, so hopefully you guys can see that whether working at the whiteboard in the classroom or in the shop turning steel into liquid or cutting with plasma, matter matters.